Good morning. My name is Kedar Vartak, and my team name is Seeking Internships, and my domain is gaming, and our problem statement is PokeChain, which is a decentralized play-to-earn gaming platform based on blockchain. So I'll just go through the entire process and show you how it's done. So this is our home page where we basically implemented a UI. This is our marketplace, which is our USP. So basically, we are providing users with an in-game currency, which is a Pokecoin, and we have developed a relation between Pokecoin and Ethereum. This is our emulator on which we have made this using Unity game engine, on which user battles different Pokemons and gains XP and Pokecoins. This is our profile where this is our user starter Pokemon, and we have implemented a dynamic evolution NFT here. So basically, the value of the NFT increases over time based on the time you spent on the platform, and you can evolve this by training it on our training grounds. So basically, I'll just go show you the process where we've implemented MetaMask as our wallet, and ERC1155 for the base entities of Pokemon. So where does ERC1155 come in handy is where in normal blockchain platforms, what the implementation of ERC tokens is that there is a one-to-one mapping of different NFT, but in gaming domain this won't be suffice, as the player scale base increases we have to accommodate more and more features and more assets. That increases the workload on us. Rather than that, we have created a base entity of every Pokemon, and the base entity has been divided into further smaller child entities, which will be owned by a particular user. So user does not own the a particular entity. User owns the base entity. Then we also implemented trading, where we won't be showing you the trading implementation because it takes time. But we have implemented a trading between this contact address and this contact address, and as it is decentralized, you can also see it on the Linea Sepolia web chain. So as our transactions are decentralized, which means that there is a complete transparency. So every user with our address will be able to search it on blockchain, and our NFT transfers are also visible. Next, we have implemented a generative AI feature for every Pokemon image, where every Pokemon image is unique. My friend Tirthraj will be explaining it to you.
Hello, this is Tirtharaj, and I'm going to be talking about the image generation pipeline for which we use in generating the NFT cards. So the main problem statement here was to create unique cards for each Pokemon which is owned by a particular user. So in order to do so, what we have done is we have used multiple models for image generation. The best one which we have come across is the Black Forest Labs Flux model. However, the thing is that it takes a lot of time for the image to generate. So in order for users to easily get the confirmation about that particular NFT, and for user experience, what we have done is we have provided a so what we have done is we have provided a asynchronous pipeline to create a image generation for the NFT. So the way it works is basically the front end sends a new NFT generation request to the post route, and over there it creates a new placeholder image at a specific path. Now that path we are going to overwrite it when we generate our image. Now what we have done is we have used Redis as a broker for queuing up the tasks, and as the image generation takes a lot of time, what happens is that one by one the tasks get consumed by our celery worker. Now this celery worker is makes synchronous calls to our Gemini, which creates a unique description of a particular NFT, and then we pass that description to the image generation model for creating that NFT. And now what we do is we replace the image on that specific path in our storage, and since front end frequently fetches periodically the NFT, the user will be able to see the new NFT image instead of the placeholder one. So these are some of the images which are generated by the model. So first is the Squirtle one, the second one is the Bulbasaur one, and the third is the Charmander one. So these are the first three starter Pokemons which are generated by the image generation model. Similarly, different types of images also can be generated. For example, this is a Charmander one, which we have, which the image generation model has generated with a unique description. These are different types of Charmander images. So this is the example of how the image, how our pipeline creates unique images for every NFT.
So this is the Flutter Android helper application which we implemented. So here is the basic login page where we are logging in the details which are stored in our Postgres database. And when we log in, this is our landing page. So basically there are some basic UI which we implemented the same in the website. This will be the game guides. These are the cards which we have available, and then here is the option to connect the wallet. So what we are doing, we are basically implementing the backend in the Express.js, and then we are basically connecting the wallet over here in our Flutter app. And as you can see, the uniquely generated NFT is also visible over here as shown by my friend Tiraj, and here the wallet address is given, and then which is mapped to the user entity we logged in before, and this is the balance, and the NFTs owned are 1. And again, a simple contact us, which you can raise an issue directly.